Hello. In the last lecture, I have introduced you to Stata, the statistical program Stata, and it was very technical lecture about how you write a program, how to load data, write a program, how to uh, draw a graph, things like that. So it was just purely software lecture, and please let me know if you had any trouble with following the lecture or installing installing Stata or anything. So working with Stata is one of the main important emphasis of this course. So please take it more seriously, and it will be useful. Believe me, it is useful in your life, in your career. So it will be really helpful for you to get a job and do well on your job. And today I'm going to talk about the interpretation aspect of the results. So once you get last time in the last lecture, I taught how to make a result, how you input data and get results. So it was just purely software, so coding. It was purely coding, but of course after you get the results, you should be able to connect the results to your knowledge. So there are many different layers. You need to get the data, and data should be transformed into results, and the results should be interpreted into your words. So we are going to focus on the second part, the interpretation, how you are going to interpret and how you read the output. So this is the one of the main we used two regression models with and without Malta. You may remember the main regression equation we were interested in. So it is a continued lecture from the previous lecture. So in the previous data lecture, the regression, it was based on homework 1. The main regression model we were interested in was about the relationship between GDP growth rate and so GDP growth rate for many countries, and each country's their trade share, which is defined as the total amount of trade divided by their GDP. So how much the sum of the import and export, how much it takes among the total GDP. So X, the regressor, is the trade share, and the outcome variable, Y variable, is the growth rate, GDP growth. It's the simplest possible model, and we had the data. The data were provided by the textbook, so we used this command. So regress growth on trade share. So intuitive. The command is really intuitive, and when you execute this command, you are going to get a table like this. So there are kind of three panels, one table, some many numbers, and another table here. So all of these are the results from this regression model. So many of those numbers are already discussed in our lecture, in the previous lectures about the regression. So today what I'm going to do here is I am going to tell you what each of those numbers means if we learn them. So some numbers are not covered in the textbook, so they are coming in the next chapter. So then we are going to skip them, but most of them, many of those results numbers are already discussed in chapter 4 of the textbook. So I'm going to explain what what they correspond to. And the problem here is the definition or the term in the textbook is different. Some terms are different from the data terms. So I would like to fix the confusions, and I'd like to match what's what, and this is what the textbook defined in a different way. Something like that. So let's go. Let's see what happens. So remember, the basic regression equation is simple. Y is determined by beta 0 plus beta 1x plus error term. So basically there are two parameters, beta 0, the intercept, and beta 1, the slope. So the beta 0 and beta 1 are two parameters in this regression model, and the beta 0 is estimated here. The beta 0 is denoted as beta 0 hat, and which means the OLS estimate of beta 0. So the intercept estimate. So OLS, remember OLS stands for ordinary least squares method. So OLS is a method to estimate, or principle to estimate those parameters given data. And here on the bar, CONS means constant. So constant, it is a constant term. Even though we do not specify the constant term or the intercept term included, we do not write that in the command, automatically Stata will include those constant, the basic constant term, so that we can estimate the intercept. So the intercept is attached to the constant term, and its standard error is calculated this way. So we discussed how the standard, what the standard error looks like in the sampling, when we discussed the sampling distribution of beta. It was complicated, but the main idea was the standard error is inversely proportional to square root of sample size, right? So standard error is proportional to 1 over square root n. So as the sample size increases, the standard error will decrease, but we cannot see the formula on the table because the Stata calculated everything for you. So this is the result of the formula you learned in the textbook. So using the formula you learned in the textbook, you get this number. So interpretation is, the interpretation of the intercept is that if a country has a trade share of 0, if there was a country who has 0 trade share, autarky, so does not trade with any other country, then the GDP growth rate is expected to be 0.64%, right? So then, what does that mean? So I don't think it has much meaning, because these days virtually there is no country who has 0 trade share. So and most of the countries in our data maybe will have quite a large trade share different from 0. So intercept itself has no economic interpretation, no economic meaning, but we need to know this to predict y, because it is a part of the function. So you need to know beta 0. So as a result, because it is far from the major the majority of observations, it does not occur in the reality. So as a result, the standard error is quite high. So estimated to be 0.64, but standard error is about 0.49, right? Approximately 0.49. So coefficient is like less than twice of the standard error, which means the coefficient is, it could be just an error, as an estimate itself could be a result of a random error. So large standard error makes the coefficient estimate unreliable, right? So that's how we interpret, and the details, how we can determine, how we can compare the size of standard error to the results, or how we reflect the size of the error in interpreting coefficient, will be discussed in chapter 5. They are discussed in those numbers. So for a while, just understand what standard error means, right? And then right above the intercept is the slope. So as you see, trade share. So this coefficient is the coefficient of trade share variable. So trade share variable's coefficient is estimated to be 2.306434, which means, so which is the OLS estimator for beta 1, right? So the same OLS method is used again. And this means if the trade share increases by 1 unit, then we expect the GDP growth rate increases by 2.3 percent point, right? So when X increases by 1 unit, and then Y will increase by this much. That is the meaning of this coefficient, which has economic interpretation, right? Trade share is positive, has a larger volume of trade, has positive effect on that economy, the growth of that economy. So it's an interesting result. And the standard error is also calculated by Stata, and it was 0.773485. Also, it was based on, it must be based on the sampling distribution formula we learned, but we skipped in the last lecture, in one of the previous lectures. So the standard error, now, if you compare these two, the coefficient is about 2.3, but the standard error is about 0.77. So relatively, the coefficient is like about 3 times larger than the standard error. So the coefficient is more safe against the potential random errors. So even if there was some random errors, not everything of the coefficient will be deleted. So the sum of the coefficient will survive even if you think some of them are result of random errors. So large coefficient relative to the standard error means something good, which means the model is good, the variable is relevant, so the relationship is clear. That's what those relative size implies. And as I said, that's the main topic of chapter 5. Okay, I am now, so we learned what those the 4 numbers means. And those are these numbers, the table below is the main results. So those 4 numbers are the main results. And in the next video, I am going to go to these numbers somewhere here. So many of them are covered in the textbook, and they will be a little more confusing. So see you in the next video.